Hello friends, welcome to Ekeeda. Title of the lecture is Per Unit Representation of a Transformer. It has been discussed before that a three-phase transformer can be represented by a single-phase transformer for obtaining per-phase solution of the system. So, I'll show you the representation of a single-phase transformer. This is a representation for a single-phase transformer. This is the primary side of the transformer and the secondary side of the transformer. So for primary side, voltage VP, voltage across primary side, current IP, impedance ZP of the primary side, and this is EP. Now for the secondary side, impedance ZS, voltage across the secondary side VS, current on the secondary side IS, and this is ES. So this figure shows representation of single phase transformer. Representation of single phase transformer. When magnetizing impedance neglected. Magnetizing impedance is neglected. So this figure shows a single phase transformer in terms of primary and secondary leakage reactance ZP and ZS. And transformer ratio is 1:A. Why 1:A? Suppose number of turns on the primary side is N1 and number of turns on the primary side is N2. Number of turns on primary side and number of turns N2 on secondary side. So ratio of N1 to N2, we can write this ratio as 1:N2 by N1, and we can refer N2 by N1 as A. N2 by N1 as A. So this is equals to 1:A. That's why transformer ratio is 1:A. Now let us choose voltage based on the primary side. Suppose voltage base on the primary side is VPB, and on the secondary side it is VSB. Also choose common volt ampere base. Now voltage across primary base, voltage across secondary base, this is equals to 1/A. Suppose this is equation number 1. This is equals to 1/A. This is equation number 1. So how this VP by VSB, this is equals to 1/A. See, EP by ES, this is equals to N1 by N2 ratio. Okay, this EP and ES is equals to N1 by N2 ratio, means number of turns on primary side upon number of turns on the secondary side. Or we can write it as VPB upon VSB, and this we know this is equals to this N1 by N2 ratio, we know this is equals to 1:A. N1 ratio N2, we know this is equals to ratio 1/A. That's why VPB upon VSB is equals to 1/A. So as volt ampere base means VA base is common, we can also write it as IPB upon ISB, this is equals to A. Equation number 2. So how is this IP by ISB, this is equals to A? See, you know, primary side current, this is equals to IA. Okay, now ratio of IP by IS, ratio of primary to the ratio of secondary current, this is equals to N2 by N1, this you know, and you know N2 by N1 is equals to A. See, this N2 by N1, this is equals to A. So we can write primary base current upon secondary base current, this is equals to A, or equation number 2. Now impedance on primary side, base impedance of primary base impedance, this is equals to VPB by IPB, this is equation number 3. And similarly for secondary side, so secondary base impedance is equals to VSB upon ISB, this is equation number 4. So from figure, see this figure, we can write that terminal voltage Vs is equals to, suppose for the secondary side first, so Vs is equals to, we can write it as equation Vs is equals to, apply KVL, so plus to minus, so Vs is equals to plus to minus means minus Vs, then minus to plus means plus Es, and minus Zs Is, or we can write it as Vs is equals to Es minus Zs Is. And now on the primary side, we can write it as EP, this is plus to minus, so minus EP, then minus to plus, this is plus and this is minus, apply KVL on the primary side, so minus to plus means plus VP, and then plus to minus is minus ZP IP, so or we can write it as EP is equals to VP minus ZP IP. This is equation number 5 and 6. I'm writing this equation here. So equation 5, this ES is the terminal voltage and EP voltage according to winding. Now see from this equation, EP by ES, we can write it as EP by ES is equals to 1 by A. EP by ES is equals to 1 by A, because EP by ES is equals to N1 by N2, and this is equals to ratio 1 by A. So from this we can write that ES is equals to A into EP. Suppose this is equation number 7. Now substitute equation 7 into equation number 5. We got the value for ES. So substitute equation 7 into equation 5. So this equation 5 is equals to Vs is equals to A into EP minus Zs into Is. Suppose this is equation number 8. Now from equation 6 we have the value for EP. So substitute EP from equation 6 into equation number 8. Substitute equation 6 into equation 8. See equation number 6, we have the value for EP. So substitute this EP value in equation number 8. So we got Vs is equals to A into EP is equals to Vp minus Zp Ip, Vp minus Zp Ip minus Zs Is. Suppose this is equation number 9. Now equation number 9 can be converted into per unit form. Equation 9 can be converted into per unit form. So see this Vs, we know this is the actual voltage Vs upon base voltage VSB is equals to Vs per unit. So Vs is equals to Vs per unit into VSB. Similarly, this Vp by VPB, this is equals to Vp per unit. So Vp is equals to, this Vs is equals to Vs per unit into VSB, and this Vp is equals to Vp per unit into VPB. Now for similarly for ZP, IP, ZS and IS. So Zp upon ZPB, this is equals to ZPPU. So we can write it as Zp is equals to ZPPU into ZPB. Now similarly for IP upon IPB, this is equals to IPPU, or we can write it as IP is equals to IPPU into IPB. Now ZSIS, similarly ZS upon ZSB is equals to ZSPU, or we can write it as ZS is equals to ZSPU into ZSB. Now similarly for IS upon ISB, actual, we know per unit is equals to actual upon base quantity. So IS is the actual current upon base current. This is equals to IS per unit. So we can write IS is equals to IS per unit into ISB. So put all these terms into equation number 9. So equation number 9 can be converted into per unit system. So we can write Vs per unit into VSB. This is equals to A into Vp minus ZpIp. So A into Vp per unit into VPB minus ZpIp. Zp per unit into ZpB into IPB, IP per unit into IPB, bracket close, minus ZSIS, minus ZS per unit ZSB, IS per unit into ISB. Suppose this is equation number 10. Now divide this equation 10 by VSB and using the base relationship of 1, 2, 3 and 4 equation. See equation number 1, 2 and 3, 4. We got, see this, we have to divide this whole equation 10 by VSB. Okay, so this VS PU, so VSB cancel out. This is equals to A into VP per unit dot VPB, and VPB by VSB is equals to 1 by A. So this VP per unit into VPB by VSB is equals to 1 by A, then minus ZP PU. So ZPB by VSB is equals to ZPB by VSB. So this is equation number 10. Now divide equation number 10. Dividing equation 10 by VSB and use the base relationship of equation number, use base relationship of equation 1, 2 and 3, 4. We get, see this VSPU dot VSB by VSB. So VSB cancel out. So this VS per unit, this is equals to A into VP PU into VPB by VSB, and this VPB by VSB from equation number 1, this is equals to 1 by A. So A into 1 by A cancel out. Similarly for other things, so this is equals to VP PU minus IP PU ZP PU minus IS PU ZS PU. So this is equation number 11. Now we can write, we have already discussed this earlier, that IP by IS means primary current upon secondary current is equals to IPB upon ISB. This is equals to N2 by N1, which is equals to A. We have discussed this earlier. Therefore, IP upon IPB, this is equals to IS upon ISB. Or we know IP upon IPB is equals to IP per unit. This is equals to IS per unit, and we can write this as current per unit. Suppose this is equation number 12. So using equation 11 and 12, using equation 11 and 12, so we can write this as Vs per unit. This is equals to Vs per unit. This is equals to Vp per unit minus this IP per unit and IS per unit. This is equals to I per unit. This IP per unit and IS per unit. This is equals to I per unit. So I per unit in bracket ZP per unit minus minus plus. So this ZP per unit plus ZS per unit. Now we can write this as Vs per unit. This is equals to Vp per unit minus Ip per unit into Z per unit, where Z per unit is equals to Zp per unit plus Zs per unit. Zp per unit plus Zs per unit. So this is equation number 13. And this is equation number 14. Now let us draw the per unit equivalent circuit of the transformer. So we got per unit equivalent circuit. For per unit equivalent circuit of the transformer, we got the Z per unit. Then this is the Vp per unit. See this equation, and this is minus plus, and this side Vs per unit. Here current. So this figure shows the per unit equivalent circuit of the transformer. Per unit equivalent circuit of the transformer. So I hope you get this equivalent circuit of the transformer. We have calculated all the this impedance, this equation number 13. So from this we draw this per unit equivalent circuit of the transformer. Now please remember that for per unit system, that impedance ZPU can be determined for both the equivalent impedance on primary or secondary side of a transformer. Like on the primary side, Z1 is equals to Zp plus Zs upon A square. So the Zp is the primary side impedance, and this Zs by A square, you know that when you go for transformer, means for transformation equivalent impedance, secondary impedance were Zs, but it is to refer, when you have to refer this for primary, it will make Zs by A square. So Zp is the primary side impedance. This is the primary side impedance. and this Z is by A square. See, you know this thing, that when you go for transformer, means for transformation equivalent impedance, so secondary impedance where ZS, this is the this ZS is the impedance on the secondary side, but when you refer this to primary, it will make ZS by A square. So both side divide by ZPB because it is referring to the primary side. So divide both side by ZP base because you are referring this to primary side. Therefore, Z1 upon ZP base, this is equals to ZP upon ZP base plus ZS upon A square into ZPB. Now, this Z1 upon ZPB, this is equals to Z1 per unit. Then ZP upon ZPB, this is equals to ZP per unit. But this ZS upon A square into ZPB, see, you know this, that see equation number 3 and 4 first. See equation this 3 and 4. So from this equation 3 and 4, you know that ZPB upon ZSB, this is equals to VPB upon IPB into ISB upon VSB. Okay. So this you know that VP, the primary voltage to the secondary voltage ratio is 1 by A, and primary current to the secondary current is A. So this is ISB by IPB, means this is 1 by A because primary current to secondary current is A and secondary current to primary current is equals to 1 by A. So this is equals to 1 by A square. So ZPB upon ZSB, this is equals to 1 by A square. So from this equation 3 and 4, we get ZPB upon ZSB is equals to 1 by A square. So we get ZPB upon ZSB is equals to 1 by A square, or ZPB into A square is equals to ZSB. So put this in this equation. So Z1 per unit, this is equals to ZP per unit plus ZS upon ZSB, and ZS upon ZSB is equals to ZP per unit. Therefore, Z1 per unit, this is equals to ZP per unit plus ZS per unit. Now this impedance on the primary per unit and impedance on the secondary per unit, secondary impedance per unit, this we can write it as Z1 per unit, this is equals to Z per unit. So this is equation number 15. So therefore, per unit impedance of a transformer is same whether computed for primary or secondary. This is the advantage. I have already told this before. This is the advantage whether you compute it for primary or secondary. Per unit impedance of a transformer is the same. So I hope you understand this topic. This is a very simple topic. This is the representation of a per unit representation of a transformer. So when we represent a three-phase transformer as a single-phase transformer, for obtaining per phase solution of the system, so this is the representation of a single-phase transformer. So primary side and secondary side, apply the KVL equation on the primary side and the secondary side. We got equation Vs is equals to Es minus Zs Is and Ep is equals to Vp minus Zp Ip. So this is Vp. So Vs is equals to Es minus Zs Is, Ep is equals to Vp minus Zp Ip. So substitute the values that we know. Ep by Es is equals to N1 by N2. So Es is equals to A into Ep. Then we know the value from equation 5. Vs equals to Es minus Zs Is, and we know Es is equals to A into Ep. So substitute this value in equation number 5. Then we get Vs, this thing. Then we know the value for Ep. Ep is equals to Vp minus Zp Ip. So substitute this equation 6 into equation number 8. So we got the value for Vs, and we know that Vs upon Vsb, that converts Vs is the actual voltage and Vsb is the base voltage, that gives the Vs per unit value. So from Like this, we got value for Vp per unit, Zp per unit, Ip per unit, Zs per unit, and Is per unit. So by substituting all the things in this equation, we got the per unit voltage value, and so substituting all this, we got the value for Vs per unit is equals to Vp per unit minus I per unit into Z per unit. So from this we make the per unit equivalent circuit of the transformer. So this is the equivalent circuit of a per unit equivalent circuit of a transformer. Thank you.